Welcome back for another deep dive. This time, we're going to be looking at the world of physics education,
Okay.
specifically the work of Professor Hwang Fu-Kwun.
Sounds good.
So we've got this webpage about a public lecture that he gave in Singapore, and it's really interesting, packed with details about his background, how he approaches teaching, even some pictures of the event.
Pictures, huh?
Yeah, it's really cool. You ready to unpack this thing?
Absolutely, yeah. It seems like a great way to look at how technology can really change how we learn physics.
Yeah, for sure. So first off, Professor Hwang's credentials are seriously impressive.
Okay.
He has a PhD from the University of Maryland,
Wow.
and he's a specialist in plasma physics.
Interesting.
But he didn't stop there. This guy has so many awards and recognition for his work in physics education.
Really?
Yeah, like including 2 physics education awards from the Physics Education Society in Taiwan.
That's amazing.
Yeah, he's got like a whole cabinet full of awards.
Yeah, impressive.
So even with all that research under his belt, he's clearly super passionate about teaching and making physics click for students.
Yeah, it sounds like it.
And his big focus seems to be using computer simulations.
Simulations, okay.
Yeah, so his website's called NTNU Java. It hosts over 1,000
1,000.
free physics simulations.
Wow.
Yeah, and it gets tons of traffic, like something like 1,500 visitors in just 4 hours.
That's a lot of people.
But what makes his approach so special? Like, what sets it apart?
Well, think about it this way. Imagine you're trying to understand gravity, right?
Yeah.
It's invisible. It acts over these huge distances.
Right.
And it's really hard to wrap your head around it just from reading a textbook.
You're telling me.
But with the simulation, you can actually see how objects behave under gravity.
Oh, I see.
You can change the variables, run
Uh-huh.
experiments, and you can really grasp the underlying principles.
That makes a lot of sense.
Yeah.
So it's not just using any old simulations, right?
Right.
He developed this thing called Easy Java Simulation.
Oh, what's that?
It lets users actually see the code
The code.
behind the simulations. They can play around with it
Wow.
and even create their own models.
That's amazing.
It's way more engaging than just passively watching a pre-made animation,
Yeah, for sure.
You're actually in there doing stuff.
Exactly. It flips the script, right? You go from passively learning to active creation.
Totally.
Students go from memorizing these formulas to really understanding the why and the how behind them.
Yeah.
They can tweak the code,
Okay.
see how those changes impact the simulation, and just develop a much deeper intuition for the physics at play.
Wow. Okay, so that's Easy Java Simulation.
That's right.
And it sounds like his public lecture went beyond just the theoretical stuff.
Oh, how so?
So the abstract mentions that he uses simulations for conceptual learning, like very specific examples,
Or like what?
like gravitational fields,
Yeah.
escape velocity, even the relationship between simple harmonic motion and circular motion.
Those are some pretty complex concepts.
Right. And those are the things that often trip students up because they're so hard to visualize.
Yeah, I could definitely see that. For example, simple harmonic motion.
Okay.
You think of a pendulum swinging back and forth.
Yeah.
It's actually very closely tied to circular motion.
Interesting.
But seeing that connection in a textbook is one thing.
Yeah.
But experiencing it through a simulation where you can see that pendulum's motion translate to a circular path.
Right.
It's like a whole other level of understanding.
So you're basically giving students these virtual tools
Exactly.
to let them experiment and learn by doing, which is way more powerful than just passively absorbing information.
Precisely. And it's not just about making physics fun,
Right.
though that's certainly a bonus.
Of course.
It's about empowering students to become these problem solvers, critical thinkers.
I like that.
They're not just memorizing facts, they're actually developing a deep understanding of these fundamental principles that govern the universe.
Wow.
Pretty cool, right?
Yeah, for sure. And the website mentions that this lecture was actually part of a larger collaboration.
Really?
Yeah, between several different schools, the Ministry of Education, and the National Institute of Education in Singapore.
Wow. That's a lot of people.
I know. It's amazing to see that kind of support for these innovative teaching approaches.
It really is.
Mhm.
Collaboration like that, it's so crucial for pushing the boundaries of education.
Totally agree.
When you bring together educators and researchers and institutions,
Yeah.
it creates such a great environment for new ideas and approaches
Yeah.
to flourish and grow. And
Yeah.
ultimately that benefits everyone,
Yeah, who does it benefit?
the students, the teachers,
Okay.
and the field of physics itself.
That's really cool.
It is.
So it wasn't all just serious lectures and equations, right?
Well, what else was there?
There are photos. You can see people actively engaged in the lecture.
Oh, cool.
And there's mention of finger food and networking opportunities, even lunch with Professor Hwang.
Oh, wow. That's great. So they're creating this really welcoming and informal atmosphere
Yeah.
that can make a huge difference in the learning experience.
Right. How so?
People feel more comfortable,
Right.
asking questions, sharing their ideas, and really just immersing themselves in the topic.
Yeah, I feel that.
Yeah.
It's like the difference between reading a textbook alone in your room
Yeah,
and having a discussion with friends who are excited about the topic.
exactly.
You just absorb and process the information so much differently
For sure.
when you're part of a community.
You got it.
It's like that feeling of, oh, I get it now,
Yeah.
instead of just like trying to force yourself to learn it by yourself.
I know exactly what you mean.
All right, so that's part 1 of our deep dive into Professor Hwang's work.
Sounds good.
Stay tuned for part 2, where we'll continue our exploration of his innovative approach to physics education.
I'm looking forward to it.
Mm.
It's really fascinating to think about the effect something like this can have, like a ripple effect.
Yeah.
Professor Hwang's just clear enthusiasm for physics,
Right.
combined with, that hands-on learning,
Yeah.
could spark a passion for science in some of those people who attended.
Totally. And, it makes you wonder, like, if Professor Hwang had access to these simulations back when he was a student,
Right.
would it have changed anything for him?
It's a good question. It's hard to know for sure,
Yeah.
but I think it shows just how powerful these tools can be,
Okay.
especially for students who might not learn best with traditional teaching.
Yeah, I agree. And it's not just students who can benefit from his work.
Right.
He made over 1,000 simulations free online.
Wow.
So teachers all over the world
Yeah.
can integrate those into their lesson plans.
That's huge.
That's a big deal.
It really is.
So I'm kind of curious, like, out of all those simulations,
Yeah.
are there any that really stand out?
To me.
Yeah, or just in general, any that, like, really show off how powerful this approach can be?
It's hard to choose just one, but I'm always drawn to the ones that explore the connection between simple harmonic motion
Okay.
and circular motion.
Yeah, why that one?
Seeing the equations is one thing,
Right?
but it's a whole other thing to watch a simulation where you see how the pendulum swing becomes a circular path.
Oh.
It just brings it to life,
Yeah, like those aha moments.
Exactly.
Where a complex idea just clicks.
Yeah.
Because you can actually see it happening.
I think that's the big advantage of simulations.
Okay.
It makes those connections that you might not get from just reading text and equations.
That makes sense.
Because, our brains are wired for visuals.
Right.
So simulations let us actually see abstract concepts.
Yeah.
But it goes beyond just seeing them. You can interact with them.
Oh, right.
You change things, try different scenarios,
Okay.
and you see how it affects the outcome. That helps you understand way more than just reading about it.
It's like active learning.
Exactly.
I like that.
So Professor Hwang really gets how important it is to make learning personal.
Social?
In what way?
So going back to that web page, the photos show him interacting with the attendees.
Right.
He just seems so approachable.
Yeah.
Like he's really passionate about sharing what he knows.
It's not like a boring lecture.
No, not at all.
It seems very casual.
Right. That personal touch makes such a difference.
Okay, how so?
Students feel like their teacher actually cares.
Yeah.
And is excited about what they're teaching.
Right.
It just creates a better learning environment.
They feel more comfortable.
Yeah, they're more likely to ask questions and really get into the topic.
It's like that difference between a textbook and a conversation.
Exactly.
It's contagious.
It makes you want to learn more.
Yeah, explore more, maybe even go into that field.
Exactly. And who knows, maybe someone at Professor Hwang's lecture will go on to make a huge discovery in physics.
Right.
Inspired by him.
I love that. Makes you think.
Yeah. It really shows how one person can make a difference. For sure. So I'm curious, what do you think Professor Hwang would say is the biggest misconception about physics?
What do people get wrong about it?
Yeah, is it too hard, too abstract?
I think he'd say the biggest problem is that people think physics is just equations.
Oh, like it's only for geniuses.
Right. And that's just not true. It's for everyone.
Because really it's about how the universe works.
Exactly. And anyone can understand that.
Yeah, it's about curiosity and just asking questions.
And Professor Hwang's work really shows that.
He makes it so clear and interesting.
Definitely. He takes something complex and makes it accessible.
Yeah, like he's saying, hey, physics isn't scary.
Yeah.
It's all around you.
And you can understand it.
It's just waiting to be explored.
Exactly.
I love that. So we've been talking a lot about Professor Hwang's approach.
Yeah. His teaching methods are really cool.
But it makes me think about where physics education is going in general.
Ooh, the big picture.
Yeah. What about the future? What role will technology play?
That's a great question. We've already got VR and AR. Yeah, those are pretty
I
amazing.
imagine a physics class where you can put on a headset and walk through an atom.
Whoa! That would be incredible.
Or see a black hole up close.
Mind-blowing.
Right. It's like those simulations, but even more real.
So immersive.
Exactly. And
Yeah.
AI is getting so much better.
Yeah. Where is that going?
We could have personalized learning for each student.
What does that look like?
Imagine an AI tutor that can explain things in a way that makes sense for you.
And give feedback.
Yeah, in real time.
That's amazing. The possibilities are endless.
It really seems that way.
But with all this technology, will we lose the human element of teaching?
That's a really important point.
Yeah, I think so too.
Because technology is a tool,
Right.
but it's just that, a tool.
You still need a good teacher.
Yes, someone who can inspire students.
That human connection is irreplaceable.
It really is. The best learning comes from combining technology with that human touch. It makes it so much easier for people to learn.
And more fun.
Yeah.
Exactly. And the best part is the more you learn about physics, the more you see how beautiful and connected everything is.
I like that idea a lot. So we talked about Professor Hwang's teaching.
Right. His methods are really unique.
But what about physics education in general? Like, where is it all headed?
That's a big question.
What role will technology play? What do you think?
Well, we're already seeing so much with VR and AR.
Yeah, it's incredible how fast it's all developing.
Right. Imagine a physics class where you put on a headset
Okay.
and you can walk through an atom
Whoa, that would be amazing.
or experience a black hole up close.
That's mind-blowing.
It's like those simulations we talked about,
Yeah,
but even more real.
you're really in it.
Exactly. It's totally immersive.
Mm.
And then there's AI.
AI is changing everything.
It really is. Think about personalized learning.
Okay.
What if every student had a lesson tailored just for them?
That would be amazing.
Right. Like an AI tutor that explains things in a way you understand.
It gives you feedback.
Exactly. And it can adapt to how you learn.
Wow, the possibilities are endless.
It feels that way, doesn't it?
But with all this amazing tech, will we lose the human element of teaching?
That's a great point. We can't forget about that.
Yeah, I worry about that sometimes.
Technology is a tool.
Right.
It can help us,
Yeah.
but it can't replace a good teacher.
It's that human connection that matters.
Yeah, someone who inspires you to learn.
That's something technology can't replicate.
Exactly. The best learning experiences have both.
Technology and a great teacher.
That's the perfect combination.
Well, I think that brings us to the end of our deep dive into Professor Hwang's work.
It's been a fascinating conversation.
Yeah, I learned a lot. His approach to teaching is really inspiring.
It really is. He's making a difference.
And it makes you think about the future of physics education.
And how we can all stay curious about the world around us.
Exactly. Thanks for joining us on this journey, and we'll see you next time for another deep dive.
See you then.